algebros. Sorry I can't be here today, but we have a very special lesson today, and we're going to talk about arithmetic sequences. So arithmetic sequences are simply a list of numbers in a special order. Each number in that sequence is going to be called a term. And then the terms of our sequence are denoted by a to the n. So this little a to the n thing right here is our terms. And they say a to the n because they can substitute whatever number they want for a to the n. So a to the 1 would be our first term. A to the 3 would be our third term, and A4 would be our fourth term. So by doing that, they can substitute and ask us to find any number in our sequence. And if you just had a to the n would be the nth term. And if you guys see 3 dots at the end, that means that pattern is going to continue forever. So let's look at a couple examples. So we see the sequence 5, 7, 9, 11, dot, dot, dot. Okay. So we want to know what is the first term of this sequence. So the very first number we see, A1, is 5. Wrong color. The fourth term, so 5 is the first one, 7 is the second, 9 is the third, 11 is our fourth. And because we're pretty smart, we know what we're doing, we can determine A5 and even A6. So if we look, 5 to 7, they added 2. 7 to 9, they added 2. 9 to 11, they added 2. So to go from the fourth term to the fifth term, absolutely, they're just going to add 2. So at 11, we add 2 to get to 13. That's the fifth term. To get to 6, we're going to add 2 and wind up at 15. So how do we determine the next number in our sequence? We simply added 2 to each term. Okay, each term was increasing by 2. Our next example. Our next sequence is 5, 2, -1, -4. Okay, A2, what is our second term? Well, that is 2. A3, what is our third term? -1. To determine A5, they didn't give us A5, they stopped at 4, but we can figure out, well, we subtracted 3, subtracted 3, subtracted 3. So to go from -4, if we're going to subtract 3, our next term, A5, would be -7. And then to go to our sixth term, we're going to subtract 3. And we get -10. So how do we get to those numbers? We subtract 3. Okay, or you could say it decreased by 3 if you want to be proper. So these two sequences are arithmetic sequences. Okay, they're arithmetic because the difference between the consecutive terms, consecutive meaning the next one in the sequence, the difference between those terms is a constant. Whatever that difference is, we're going to call that a common difference. And it gets denoted with the symbol D. So that little lowercase d is going to be our common difference. Okay, so we look at our sequence 5, 7, 9, 11. What's our common difference? So we're going up by 2 each time. So +2, +2, +2. So our common difference is 2. Next one, same thing. We're looking at the difference. 5 to 2 is -3. 2 to -1 is -3. -1 to -4 is -3. So our common difference is -3. So we want to write the first 4 terms of our sequence. If the first term is -5 and the common difference is +5. So we're going to use our squiggly brackets because we've got a series of numbers. And our first term is going to start with -5. Well, if we're common difference is +5, we're going to add 5 to -5, get 0. Same thing, add 5 to 0, get 5. Add 5 to 5 and get 10. And then our sequence is going to continue, so we need our ellipses. Same thing for the next one. They give us the first term of 2 and a common difference of -4. So our first term is going to be +2. Subtract the common difference of 4 to get to -2. Subtract 4 to get to -6. Subtract 4 to get to -10. Don't forget your ellipses. Our dot, dot, dot. You know, like the movies, they make it all dramatic. Dun, dun, dun. Angry Beaver looking at you. So we can use this in our tables as well. Okay. Auditorium has got, the first row has 7 chairs. Every row after that has 3 additional chairs. Okay. How many chairs did the 20th row have? Okay. Now we can continuously add 3 20 different times, but let's see if we can't develop a formula, an equation, because math gets easier with equations, to make our process a little simpler. So you can kind of see in the table, n is our number of rows, an is our chairs, right? So the first row's got 7. We're adding 3 gets us to 10. Add 3 gets us to 13. Add 3 gets us to 16. So to calculate the second term, we added 3 to the first term. To calculate the third, you would add 3 twice to the first term. To calculate the fourth, you would add 3 times to the first term. So to calculate the nth term, remember we represent the nth term with an n. So to calculate the nth term, we're going to add 3 n minus 1 times. Okay, because if you kind of look back up, the second term we added it once. The third term we added it twice. Fourth term we added it 3 times. So whatever number we're on, we're going to subtract 1, and that's our term. So we can represent this additional repeated addition instead of saying, and I'm going to just keep adding 16 until I get to 20. Forget what Coach O says. This is going to save me so much time. Negative, Ghost Rider. Okay, we can represent repeated addition using multiplication. So to calculate an, we're going to calculate 3 times n minus 1 plus the first term. So we look at our first example, a to the 20. Okay, 20 goes in for n. So a to the 20, 20 goes in for n. Pop that into our calculator. Or forget, it's okay. So we get 3 times 19 plus 7. And then 3 times 19 is, survey says, 57. And then 57 minus 7, or plus 7, excuse me. Read your own handwriting, knucklehead, is 64. So it would have taken you quite a while to add 3. add 3, add 3, add 3. You would have gotten there. You're 100% correct. I'm not going to argue on that. However, time is your friend, and why waste time when you can be productive with it? So let's say we're given A1 is 10. So our starting number is 10. So that would be this first one down here in the bottom, off to the side. A common difference of -5, and they want us to find when A is the 20th term. So we go 20 minus 1. Okay. So we get -5 times 19. Remember PEMDAS, this inside our parentheses takes place before that multiplication happens. Plus 10. -5 times 19 is -95. And -95 plus 10 is -85. And we can do this for the next term if we want it. We can find the 50th term. I'll give it to you. Maybe I can get to 20 quicker. Maybe. Probably not. However, I know for sure that it's going to take you a hot minute to get all the way to 50. Okay, so remember, we put a to the 50 equals, our common difference is -5. N is now 50 minus 1, plus our starting number 10. So we get -5 times 49 plus 10. -5 times 49 is -245. And then -245 plus 10 is -235. So yeah, I mean, that would have taken you a long time to go by 5s 50 times. Okay, our next example, our first number is -2. So you can kind of see the formula below. AN equals D, the common difference, in the term in the sequence, and A1, our starting term, our first number. Okay, so we're using that formula to solve this one. So A33, all right, so our common difference is 8. N minus 1 would be 33 minus 1. And then they started us at -2, so we get -2. Eight times 32 minus 2 is 256. And 256 minus 2 is 254. So that equation can make your life easier. So we're going to practice a couple down here. You just got a brand new book and you're excited. Okay, so the first day of reading your book, you read through until page 15. Every day after that, you read 6 more pages. What page, do you end on after the 10th day of reading? So we want A10. Our common difference is 6 pages per day. N is 10 minus 1. And then our first number where we started would be plus 15. So we get 6 times 9 plus 15. 6 times 9 is 54. And 54 plus 15 means you stopped on the 69th page after 10 days. Really savoring that book. Right? On the first day of the new year, you had $200. Every day after that, you spent $250 on a drink. How much money do you have on the 45th day of the year? Okay, so if you think back, we kind of figured out that the common difference was what our D was. So we want to know 200 is how much we started with. 45 is the day they want us to figure out. So the common difference is 250. But we are spending 250. We are not saving 250. So that common difference is actually a negative. So A on the 45th day, A45, of a common difference of negative 2.5. 45 is our N. And because we started with 200, we have 200 in our book. Okay. So negative 2.5 times 44. Negative 2.5 times 44 is negative 110. And then negative 110 plus 200 is 90. So just on drinking soda, you've spent $110 in a month and a half. That should make you think about what you're doing to your parents at lunchtime every day. Okay, so now let's say that we've got two terms of an arithmetic sequence. Can we calculate our common difference? If we know A1 is 2 and A4 is 17, let's calculate D. Let's recall that our formula is AN equals D times N minus 1 plus A1. Using this formula, we can substitute the given values. Okay, so our first term is A4. Wish they would have gave us a little bit more room here. Equals D N minus 1 plus A1. So we know A4 is 17. Guys, I'm going to move my work up here a little bit, just so I've got a little bit more room to work with. All right. So A4 is 17. Okay, D is our unknown. And we're on the fourth number, so we're substituting a 4. And then plus a 1, which was 2. Okay. So we're going to combine like terms underneath that parentheses, and we end up with 4 minus 1, which is 3D, plus 2. And man, would you look at that? It's just a basic linear algebra problem now. So we're going to subtract 2 from both sides. So 15 equals 3D. Divide both sides by 3. So D, of course, well, we won't maybe, go Paladins, equals 5. So D equals 5. Okay, and we can do the same thing if they said, hey, instead of the fourth term, how about you go ahead and find the 40th term? Say what? Okay, so A to the 40, D N minus 1 plus A1. Okay. So we know now what our common difference is. Oh, let's get my little box down, Chandra. Hey, we know what our common difference is. So we're just substituting that 5, 40 minus 1, plus 2. We know the common difference is 5. So 5 times 39 plus 2. 5 times 39 is 195. So our 40th term would be 197. So we can kind of reverse engineer it to work. do this practice down here. So A1 is 14. A5 is 38. So when we set up our equation to find our common difference, we're starting with A5, D n minus 1 plus A1. And then we just substitute the players into the game. A5 is 38. D is our unknown. We're on the 5th term of the sequence, so the 5 goes in our parentheses. And then plus 14. We're going to subtract 14 from both sides. 38 minus 14 is 24, which equals 4D. Divide both sides by 4. So we found D to be 6. So now that we know what D is, we can determine any number in that sequence. So arithmetic sequences can also be expressed recursively. And no, we're not talking about that thing in 3rd grade that your English teacher told you would always happen in high school. Recursively is simply a repeated application of a rule. Meaning, if we want to find something, to determine it, we can always take the previous term and add the common difference. That's what you guys were doing at the beginning. Hey, I'm just adding 2 to the next term in the sequence. I'm just 4, 0, negative 4, negative 8, 4. So recursively, same thing. How do we get from 5 to equals an minus 1? You need to know what's happening in the sequence. You need to see that number. It'll be a little tough. To negative 2, we subtract 7. Negative 2 to negative 9 over again. So again, we're a to the n equals. I don't like that one as much. However, that is technically how that formula would be officially written instead of you guys just count. All right, the last thing we're going to talk about is 1, 2, 2, 4, 4, 6, or 3, 6, 4, 8. And I want you guys to notice, we just talked about linears, quadratics, and exponential speed. Absolutely, it's going to be a linear graph. The graph above is linear. Every single arithmetic sequence is linear because of the common difference. The common difference is a constant. It's either going up by the exact same number or it's going down by the exact same number. Because of that, our common difference is very close, and it really is slope, which is just a fancy way to say rate of change. Guys, thank you so much for your attention. Okay. Go ahead and get the last 2 sheets done for homework, and I hope to see you tomorrow.